Over the last few videos, we have developed the first part of the theory of the consumer, which has to do with how to derive the demand function and what are the properties of this demand function, how it varies with parameters of the environment, such as prices, etc. Now we're going to look at another essential component of the theory of the consumer, which has to do with the well-being of the consumer. We're going to develop tools that are going to allow us to ask questions like, when a price changes, is the consumer better off or worse off? And if so, exactly by how much? As we will see, the tools that we will develop here to measure the welfare of the consumer, or well, by the way, economists use the word welfare and well-being interchangeably, so don't be confused by that. But these tools that we will develop will have a countless number of applications throughout the rest of the course. So it's important that we learn them well. A critical concept in studying the welfare of the consumer is the notion of consumer surplus. We're going to denote by CS of P the consumer surplus of the consumer at price P. And the definition of what the consumer surplus at price P is exactly what is given here. It's the difference between two terms. Let's think about what this term means. This term is the experience utility at the optimal choice. Let's see why that is the case. This is the utility of consuming the optimal level of X and the amount of M that remains after you have paid what it costs to buy the optimal amount of X. Now, the second term is simply the experience utility at the initial allocation or at a no-trade allocation, and in which the consumer basically gets its initial level of the M composite good, but is not allowed to buy anything after that. Now, what do the difference in these two terms mean? If you think about it, is the difference between what you get at the optimal allocation when you can buy what you want minus the utility when you cannot buy anything at all. So this is basically intuitively, this is something like the gains from trade, from being able to buy what you want. And we can think of this as the net benefit from buying optimally at price P. Now, remember that under the quasi-linear preferences or experience utility that we have been studying, both this U and this U are measured in dollars, and therefore the units of the consumer surplus are dollars. Now, we're going to do some algebra to provide a more useful representation or description of what is consumer surplus. So let's go from here and substitute the functional form of the utility function. So this is going to be equal to B of X star of P plus W minus P X star of P. This is just the first term. Now I'm going to write in red to help you keep track of this, the second term, which is minus B of 0 plus W. This is the utility when you're not trading. Now, let's rearrange this a tiny bit. But first notice, sorry, that the W's cancel. And now we can rearrange this as follows, which is B of X star P minus B of 0. I'm going to call that one term, minus P X star of P. Notice that this has a very nice intuition for understanding why this is the net benefit from making the optimal choice. This term is just the cost of buying X star. And this term is the change in benefits from buying X star. So that's why it's the net benefit. It's by how much the benefits go up minus what was the cost of buying them. Now, the next thing we're going to do is we are going to dig deep into your memory for a very basic calculus result, so we can expand this out as an integral. And if you remember from calculus, we can write this as the integral from 0 to x star of p of b prime of x dx. That's just the fundamental theorem of calculus. Similarly, we can write this term, and I'm just doing this to help you with the math, it's not really necessary, as minus the integral from 0 to x star of p dx. If you solve this integral, you will get that term. Now, by the basic linear properties of the integral that you learn in calculus, we can bring the two terms together into a single integral and write the following, that the consumer surplus at p is equal to an integral from 0 to the demand of b prime of x minus p dx. This is a very important formula that you should commit to memory, because you're going to use it in many, many problems in this unit and beyond. Now, it turns out that the formula of consumer surplus that we have just derived, that I am copying here for your convenience, allow us to provide a very nice graphical description or interpretation of what consumer surplus is. So let me do that for you. Look at the axis, at the graph that we have done, in which you have x here, and you have the marginal benefit function here as a function of x. Okay. Now, what is the consumer surplus at any price p? Say this one. The formula is telling us that it's basically the sum of two integrals, one related to the marginal benefit and one related to this price, from 0, from here, 0, to x star of p. Okay, and let me color the terms differently to make this easy to see. So let's look at the first term here first. The integral from 0 x star of p of b of x dx. That basically is the change in benefit. And graphically, that integral is the area under the marginal benefit curve from 0 to x star of p, to the demand, or the level demanded. That is this area. Okay? Now, the other term is basically just this p dx from 0 to x star of p, which, if you remember, just look back at your notes, is just the cost of buying the level demanded, the x star of p. But that is just this area. And you take a moment to convince yourself if this is not obvious to you. This area is how much it costs to buy x star of p at price p. But what do we learn then? That since the consumer surplus is the difference between these two areas, is basically given by this, by this area. This is the consumer surplus at p. It is the area from 0 to x star of p, or the level demanded, below the marginal benefit curve and above the price line. It's just that area. That's very nice. If you have a graphical representation of this, or you know the marginal benefit function, or you know the experience utility function, any of these things will allow you to apply the formula, or in some cases even geometrically, and compute this area, which will give you exactly what the consumer surplus is at that price. Finally, let me highlight a couple of basic properties of the consumer surplus. The first one is that it is always non-negative, and the second one, that is positive only when X star is positive. If the level demanded is 0, CS of P, the consumer surplus, is 0. Now, I want to show you how to kind of prove or establish these results using two very different types of logic that can be applied to this. The first one is just the graphical intuition, the graphical argument. And we just have shown that consumer surplus, this is a marginal benefit function, let's say at a price like P, is basically, remember this is the level demanded, is going to be basically this area. Now, we know that areas are non-negative. If the area is kind of non-existent, is 0, but otherwise it's a positive thing, which proves the first part. And it's easy to see that the only way the surplus can be 0 is if the consumer is demanding, let's say at a point, at a price, suppose that the marginal benefit function crosses there, at which the demand is positive. If the price was so high that the consumer was demanding nothing, the area under the curve would be 0. And that immediately proves this. It just follows directly from the fact that the consumer surplus is that area. The other way of establishing the results is based on a type of argument that economists call a revealed preference argument. Revealed preference. Together with the Spanglish, sometimes I cannot spell. So, a revealed preference argument. Let's see how it looks. Remember that the consumer surplus is basically the net benefit from moving to a situation in which you demand nothing to a situation in which you demand the optimal amount. Now, since you can always choose nothing, so 0, W is feasible, since that is feasible, it has to be the case that the move to X star of P makes you better off, or makes the consumer better off. Why? That's where the revealed preference comes in, because otherwise the consumer would not have bought the item. He would have done 0W, which is feasible. Now, since this, by revealed preferences, this change have to increase the well-being of the consumer, this establishes that the consumer surplus has to be non-negative. Now, the consumer is not going to move unless he gains something, which shows you that when this is positive, this is going to be positive. And if the consumer demands nothing, basically it's consuming the same thing in both cases, and there is no net benefit, which shows that when the demand is 0, the consumer surplus is 0.